So welcome to the homework problem of week 7, where we are going to compare the CO stage of acetone and acetyl chloride with that of the formaldehyde. We are supposed to use B3 leaf dep2 TZVP, and we have already calculated the H2CO and the scaled version. The scaling factor we have used is 0.985. So let us first start with the acetone. So let me make a new folder called homework. Let us start Avogadro. Now let's make the double bond and need to add another carbon to make it an acetone. Has to be single bond, and let me do a quick optimization. Week 7. I could have just directly make the input file. So generally it's a good idea first to optimize with a smaller basis set. So you have saved acetone dot INP. I will open in Movax term. So it's Orca Maybe I should have done an XTB optimization first. It's a good idea sometime to do an XTB optimization first and then try to do the DFT optimization. Maybe for the acetyl chloride we will use that trick. So now the geometry optimization has been converged. That's doing the final energy calculation. So it took around 21 minutes. Maybe I should have done the XTB optimization before. So now what I will do is I will open the input file. Now I will make it TZVP. I will start with the already optimized XYZ file. So now let me resubmit the job again. Now the optimization in the new basis is also done. I could have just calculate now the frequency. And let me create another directory inside this. Name acetyl chloride. So for the acetone now I can calculate the frequency. Let me start the Avogadro again. So, now I have to make the acetyl chloride. So, I will start with a methane, put another carbon, and now I have to put a Cl group here. Can do a quick optimization. And I will generate the Orca input file. Let me make two things. First, let me opt with an XTB. And we need to calculate the frequency, and let me now run it parallelly. We have not discussed anything about running in parallel, and we have not discussed anything about running in Linux environment. So, this is what I am going to do, because the jobs will take too much time. Let me save it in the acetyl chloride. So, let us go to this directory acetyl chloride, and now let us open a MobaXterm here. So, I will now run calculation in a Linux machine which is not in this laptop, but somewhere remote. So, I will connect with SSH. MobaXterm allows you to connect with SSH, and I will run these IPs individual for each machine. So, if you have an access to the Linux, you should get the IP, and generally if you connect with SSH, it will ask for your password. So, my password is saved, so it is fine. And it says it follows the terminal folder. Now, I will go to the directory called Achintya. You should always run your calculation in your own machine. And now I want to put the input file I just prepared there. So, I will click into this. Let me show it again. I click into this upload to current folder button. I come to NPTEL week 7 IR homework acetyl chloride and acetyl chloride dot input file. So, now you see that acetyl chloride dot input file is here. Now, VI is the Vim editor. I opened it out, I said PAL 8, cal frequency true, RHF opt XTB. Now, this machine I can do two things. First of all, I can see how many processors are available, and the command is to read it from the CPU info. So, it says that it is processor up to 11 starting from 0, they are not processors actually, they are cores of the same processors. So, it starts from 0 and it has 12 cores. I am using 8 cores because I wanted to. So, maximum you can give 12 cores. Generally, it is a good idea to give less number of cores than what is available. Now, if I run it, okay, this command is wrong. To be really honest, I forgot the command, and this can be also happen to you, but not a big problem because I can always go to the geometry optimization slide. Calcation is equal to true, not cal frequency. So, I can always copy paste from the manual or where I know the correct values are. So, you do not need to remember these commands. And recalculation 5 step might be too much. Let me copy. I can make it each 15 step. Now, I try to run. And it shows some error, and the error says, if I open the output file, Orca has to be called with the full path name, and that the error you will see if you try to run just with Orca. You have to run, if you just run with Orca for the serial job, it will run fine, but if you want to have parallel job, of course, you have to install the MPI. I have not shown how to install MPI. You can see it in the Orca manual how to install MPI and do other things. So, you have to first find out what is the correct path. So, you can say type which Orca. So, this is the full path of the Orca. I am using the 5.03, but should be fine. And now I give acetyl chloride, so it says that O2 XTB is not available. Just copy this version to the just edit this portion. Okay, let me try to optimize it directly using B3 lip. There's some problem with the F2 SPP. So the single point job has been done. Now I can remove the recalculate Hessian 2 and start it as an XYZ file. Let me calculate the frequency here only. So you can see how fast it's running parallel and on a dedicated Linux clusters. So now my calculation is done. So you see that this file on the right hand side are still not updated. So now they are now updated. Now what I can do, I can take the output file and download it to your local machine. Local machine, I want to download it at week 7, IR, homework, acetaldehyde. So now I bring it here. So it just took 1 minute. And now the output file is here. I can open it with the Chemcraft This is the CO frequency. And I can go to the tools. I can scale the x axis. So unscaled value is 1880.79. And if I use the scaling of 0.985, it becomes 8.52. So this job is still running. What I can do here, I can upload the acetone.inp and acetone.xyz file. And I can just use PAL 8 to make it faster. So this calculation, you see that has been done before 1 minute. So I can again download it. I have to refresh first. I need the acetone.out. I need to download it. I want to put it in week 7 homework. One problem is that this might overwrite by this file. No, I should have. Actually, this file is possible to be opened by ChemCraft also. So if I go to open with this one, so you can actually open the remote file using ChemCraft and Movaxterm. Try. So, it is there. So, this is the acetone CO frequency. So, go to the source spectrum. So, this is the unscaled frequency. And if I scale it with it's 17.59. So, if you compare with the formaldehyde, in the case of acetone, the higher stretching frequency actually gets reduced in terms of in the case of acetyl chloride, they get increased, and it is observed both in the scaled and the unscaled version. So, you may try to think in why in the case of acetyl chloride they have increased and why in the case of acetone it has decreased.